All right, another way to make a power series, a function into a power series, is basically adding and subtracting two functions. So that's where this g of x power series is coming from. So I can add and subtract the terms, term by term, the f and the g here, in order to get a new power series. Apparently, we're supposed to see the next example. Okay, so example find 5. Find a power series for f of x is equal to 3x minus 1 over x squared minus 1. Are you kidding? This doesn't look anything like what we've done before. Not at all. Oh, okay, we got a bit of an animation here. And oh, math is supposed to happen. And apparently that math involves some partial fraction decomposition. All right, let's see where it takes us. All right, I've got a 3x minus 1 on top. And on the bottom, x squared minus 1, but I need to factor that guy, x plus 1, x minus 1, and then assume that there are partial fractions it decomposes into as an a over the first factor, x plus 1, plus b over the second one, x minus 1. Right? Okay. And then I am going to multiply both sides of this by that common denominator. Cancels out on the left-hand side, because that's what we want. And then over here on the left-hand side, this first factor will cancel out and leave us with the other factor of an x minus 1. Same thing will happen on a b, and it'll get the opposite factor of x plus 1. All right, our basic equation. This is one that's super easy to solve if we just choose some convenient values of x, like 1. All right, what happens when we put in 1? So I'd have a 3 there, minus 1 is a 2, is equal to, the a goes away by design, and then over here I have a 2b. 2b, or, and then that implies that b is equal to 1. All right, so we've got our first value. And then for the second one, a convenient value would be a negative 1 to make the b disappear. X equals negative 1. Over here, when I stick in a negative 1, I get a negative 3 minus 1, I get a negative 4, is equal to negative 1 minus 1 is a negative 2a. And then dividing, we get an a is equal to positive 2. And then rewriting our fractions in partial fractions, I would have 3x minus 1 over x squared minus 1 is equal to, our a value is 2. That went over the factor x plus 1 over x minus 1. All right, so here's how it helped us, because now these do look like something that I can turn into a geometric series, but then I just kind of have to rearrange stuff a little bit. All right, so let's do that rearrangement, that algebraic manipulation. 2 over, make that a 1, and then minus a negative x there. And then over here, let's see. I am going to have to, like this guy right there's got to be positive, so I'm going to have to fix that. So here, let's turn stuff around first. So a negative 1 plus x. All right, let's basically divide everything by negative 1, by negative 1, by negative 1. All right, bring this stuff down. And then I have a negative equals, no, come on. Actually, I'll just bring that negative out. Minus 1 over, I'd have 1 minus x, and then, hey, we know what this one is. We've seen this one. We have to have it memorized. All right, and then this one has a first term of a 2. So I'm going to basically make this as two different series and then just subtract them like this. I have the series from n equals 0 to infinity. This first one starts with the number 2 and then has a common ratio of a negative x raised to the nth. And then minus, I can make this one as a series, n equals 0 to infinity. And then this one is just good old-fashioned x to the nth power. Yay, we like that guy. All right, and then It's just basically term by term, I am subtracting these two power series in order to make a new one. And while I'm at it, I might as well take this -1 out as an alternator and make that equal to our series of 2 times -1 to the nth power, x to the nth power, and then minus x to the nth as one complete series. Since these things have a common factor of x to the n, you could, if you wanted to, you could totally pull that out and make that x to the n times, you have 2, -1 to the nth, and then that would be -1. That would work too. All right, so we did lots of algebraic manipulation in order to make our function into a power series. Next up, we're going to do a little bit of calculus in order to get there.